Hello out there. Welcome today. So the lesson for today will be focusing on probability, but not just only probability. We'll split this into tree diagrams and contingency table. Okay? Remember out there at home, don't just observe only. You need a pen and paper, you need your calculator, where you'll scribble some of mathematics. That's the only way we study mathematics, not by observing. We practice, and we try problems. And I really encourage you to try some of the problems with us. Okay, let's see what we have today. So on the probability. So before we do that, what do you think, or have you ever thought about this? What is the likelihood, when I talk about probability or likelihood, just saying the same thing, of contracting a COVID-19 at the bar? Okay, so I'll encourage you to do a little bit of research and just check that, because usually at the bar, while you're drinking your coffee or whatever, you don't wear your mask. And the data does show that there's a higher chance of getting the COVID-19 if you go to a bar. Are we together? Hence, they actually put lots and lots of restrictions on that. So, but I'd like you to research, just check what is actually the chance of getting that, and compare it probably to school, okay? So you find there's actually a higher likelihood or probability. And how do they arrive to that probability and conclude that, yes, there's a high chance? By collecting data. Collecting data and people who test positive. And they can see that the higher proportion who actually go out or those social distance are contracting the COVID-19. Fantastic. Let's see how we'll apply this in our life. So, but before we do that, I did indicate we'll look at probability, we'll look at tree diagram, and after looking at the tree diagram, we'll also look at the contingency table. Okay, let's start with tree diagrams. Some of the key words you need for your tree diagram. It's a sample space. What is a sample space? Okay. If I'm in a class with what? Chairs and table. Are we together? And I'm looking at that. So the sample space will be the numbers of chairs and table in the class, the total. Are we together? If I go in a class with boys and girls, I want to count how many boys and girls in that class will be how many boys and girls. Okay, so that'll be the sample space. And the possible outcome. So those will be actually if you add, that is a total possible outcome. Are we all together? Okay. So very important, the probability, to understand what is a sample space, understand the possible outcome. Okay. If I flip a coin, what is a possible outcome? I can get a tail, a head. Those are the two possible outcomes. But if I have a die, I have 6 possible outcomes which can come. 1, 2, 3, 4, 5, 6. If you have a fair die, you know there's 6 numbers there. So sample space and possible outcomes, almost kind of similar. Just the possible outcomes is what can come from rolling a die or flipping a coin. Okay. What is an event? We know an event. If I have a die, the probability that 1 occurs, that will be an event. Are we together? Or 2, or 3, or 4. Also, if I have a coin, we can have a chance of getting tail or head. So those are the 2 possible outcomes which we can get from there. Some of the keywords, also independent and dependent events. Independent, you can see, come from being independent as a person. Dependent, depends on something. Okay, so independent, let's look at dependent. Dependent will depend on the other outcome. Are we all together? So in probability, some outcomes are affected by other outcomes. Are we together? Let's look at flipping a coin. If I flip a coin, I get head or tail. Me getting head now, does it affect me, the next outcome? No, it's not. Are we all together? It's not affected by that. Okay, so we'll look at actual examples later when we look at dependent and independent events. Okay. Okay, so a tree diagram are useful for organizing and visualizing different possible outcomes of a sequence of events. So each branch in the tree shows outcomes of an event along with the probability of that outcome. Okay, I'll show you with an example. For each possible outcome, the first event, we draw a line, okay? We write down the probability for that outcome and state the event if that outcome happened, okay? So if I have a coin, okay, I could have head or tail. So I will draw a line of that nature, are we together? Which is tail or head, okay? So it's an event, tail or head. That's the tree diagram, okay? So now there's an example using the tree diagram to determine the possible outcomes when a coin is tossed. We're together. So we're going to toss a coin. If we toss a coin, we can get what? Head or tail. And here we're assuming we're going to toss it twice. So you can draw a tree diagram tossing a coin once, twice, 3 times, 4 times. Okay? So we're going to look at twice. So we're looking at a coin. If we toss first time, we can get head or tail. Are we all together? If head occurred and we toss again, head does not affect the next outcome. Are we together? So we can still get head or tail. Are we together? We could have tossed the coin and the outcome was tail. If the outcome is tail and we toss again, we can still get what? Head or tail. Are we together? Then the possible outcomes, those are the possible outcomes. If you toss it twice, we could get head, head. Are we together? Head, tail, tail head, and head, head. Are we together? So we have what? 4 possible outcomes. If we can toss what? A coin twice. So then the sample space, which is S, it will be HH for head, 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 tail, tail, head, and tail, tail. Now, let's look at another tree diagram. But this tree diagram, we want to take a coin and a die, and we're going to throw those together simultaneously. And how do we draw a tree diagram? Okay, for that. So suppose a coin is tossed and a die is thrown. We can represent the possible outcomes in a tree diagram. So if a coin can give us what? Head or tail. Are we together? If a coin gives us head or tail, what about a die? A die can give us 6, 2, 3, 4, 5, 6. Are we together? And also it can give us, if we get tail, a die can give us 1, 2, 3, 4, 5, 6. Are we all together? So if we roll a die and a coin, we can get 6 and tail. Head or 7. Not 7. 7 is not a sample space because a die you have 1, 2, 6. Okay? Are we all together? Now the possible outcome can be head 1, which can occur, head 2, head 3, head 4, and head 5, head 6. And tail can come with 1, tail can come with 2, tail can come with 3, tail can come with 4, 5, or 6. Are we all together? Those will be the possible outcomes. So, independent event. Let's talk about independent event. So 2 successive events, A and B, are said to be independent if the outcome of the first do not influence the outcome of the second event. Are we together? Event A happens, then is followed by event B. Okay? Suppose that event A is tossing a coin. Event B is throwing a die. The chance of getting a particular number on a die, second event, will not be affected by the chance of the first getting head or tail, with the coin being first event. In general, in mathematics, we'll use this formula to test whether an event is statistically independent or when we calculate probability given that they are independent. So the probability of A and B will be what? The probability of A multiplied by the probability of B. Given they are independent. If they're not independent, you cannot apply that. Are we together? So the tree diagram we drew, that shows independent. Tossing a coin does not affect me getting a tail next. Are we together? Flipping a coin and a die, independent. Are we all together? Fantastic. When we come back now, we'll look at more and more tree diagram. Sit there and relax and keep working hard. We'll see you shortly after the break.